Hello guys and welcome in this episode. Today I wanted to give you an overview on the progress that we made concerning the planet rendering. I have been working on that for a while now, and in fact I have already posted a few recordings, only one recordings I guess. And this is the initial step that we had, so displaying 6 terrains, so those Proland terrains, so displaying 6 of them on a cube to try to build a planet by then shaping those 6 terrain in the shape of a sphere. So this is basically what is explained here in the terrain deformation part concerning Proland. You start basically with a flat surface and you're going to apply some deformations to get to your spherical shape. And you have here, for instance, the cube terrains on the outside part, and then this would be, well, shrink and move onto the sphere surface itself. So we have been working on that, and the results are pretty interesting so far. So let's have a look already. Here we go. The spherical shape planet built from those 6 terrains. And what I have also added is a new camera controller. So this is called the planet camera controller in my implementation. It's similar to the planet view controller, I guess, in Proland. And you can use that to basically always focus on a given point on the surface of your planet. So this is your target point here for the camera, and you're going to be able to move around this point and vertically also around the zenith axis at this current location. And you can also zoom in, of course, still focusing on the same point here. Oh, that's an interesting one. Yeah, I'm still working on this planet controller because it's not really working as I was expecting. So I still need to do some stuff on that. And lately I introduced a modification which apparently is messing things even further. Okay, good. We'll get back to this. Anyway, you can also, in fact, move around. So you can move forward and also backward, and then left and right using some of the keys on the keyboard, which is actually going to modify the target point that you have on the surface on the Earth, but not modify your current view position with respect to this target point. And this gives you this kind of movement effect. You are changing your focus, and you can at any time start turning around your focus at point. What else do we need to mention? Yes, currently what we have is in fact just a flat surface, as you can see when we get close to it. There is no elevation anymore. Oh, interesting. We have a, I guess that's a limit of the near plane. I hope so. And the next step I'm going to take is going to add support for those elevations. But this is a bit more tricky than one would expect. You cannot really use your elevation directly because you have to apply the deformation also to your normals and so on. So I need to be careful about that. And it was already pretty tricky to update the shader. Let's have a look at the shader. In fact, it's a sphere terrain to be able to include the spherical deformation elements. Okay, actually there is some merge going on here because now we have this utils file for the terrain. I don't think I mentioned that in the previous recording. And we're placing some of the command elements here. And here you have, for instance, information concerning your quads. We basically have a buffer where we store information for every single quad that we are going to render, and now we are extending the information here with additional data. So we have a vec4 but also 3 additional matrices here, and this are what you will use then to compute the deformation in the shader. We do that somewhere around here basically. Let me see, I probably have that also in the reference implementation, which is going to be somewhere around here. Let me find that. Alright, so here we have the terrain shader program for the terrain number 2 example, which is this planet construction with those 6 terrains. Terrain nodes are here. And I took the reference implementation from here. This part was already available in the first version, and now we have this part going on for the deformation itself. The interesting thing here is here we're working directly, in fact, in the screen space, which is not something I've been doing before, actually. But that's fun. Everything you get is already in screen space, which means that when it's time to compute your actual position, there is no matrix transformation anymore because it's already done for, I mean, this is a matrix transformation, but there's no change of your reference frame, I guess. It's just a mix of those different vectors that are provided here as input, those corners and the normals, I mean the verticals for those vectors and so on. I'm not quite sure to understand in fact what the computation is doing here. Yeah, I could go more carefully about that, but if you copy that properly, it's just working, so they don't need to worry too much about it. Okay, what else should we mention concerning this planet? Also, the upsampling part, I think, is not done correctly. I mean, one thing which is obvious is for the 6 terrains that I'm using currently, I'm using the same kind of noise pattern, because all of them are considered to be a single face on the terrain, and I need to change that. I think normally you should have a different face for each terrain, and you could generate a noise that is continuous on the planet, on the full planet surface, to kind of avoid those links. Because right now, yeah, those terrains are not matching, and I will need to fix this part. And what else? Also, as I mentioned, my planet controller is not really working fine. The major issue I still have is this gimbal lock. If I keep working forward and getting close to a pole on the planet, one of them is here, I believe. So let me try to do that. If I just move forward, eventually you get to the pole and you're stuck. That's not good. I need to, I guess, I mean, yeah, I know where this is coming from. It's because when I'm computing some kind of canonical reference frame for every single location that I'm pointing at, I'm using this vertical axis to give me the the canonical frame. But I should not do that. I should really use a instantaneous frame based on the previous view orientation and so on. So I'll be updating that very soon. And we also have support to control the speed of the camera. So for instance, whoops, if I decrease the speed here, it's going to reduce it, and if I increase that, it's going to make it actually too fast. And I've been refactoring a little bit my camera controller, in fact, to make this speed management, well, a shared property in the camera controller. I mean, that's not really important, I guess. And I think this is it. Is there anything else I forgot to mention? What was mentioned on this page? What did I need to talk about here? Nothing, already. Okay, cool. So, yep, I guess this is it. A short recording for once. And as I said, next step is to try to improve a little bit further on the Proland controller and then try to provide some elevation on the terrain, and make another recording when I get something a bit more looking like a real planet with elevations. As usual, if you have any question, let me know in the comment, and otherwise, keep coding on your side, and have a nice day. Bye bye.